Hi, this is Bruce Perrins, K6BP, and this is about the $14 remote rig controller. So this is a hamopen.org project. Hamopen.org supports development of technology for amateur radio. See our website at hamopen.org. This is my remote site. And this is about 45 minutes south of Klamath Falls, about a 5-hour drive from my home in Berkeley. It's over a few ridges from Lava Beds National Monument. You can see the geography is similar. It's between Mount Shasta and Mount McLaughlin. They're both visible in the distance, not in the photo. And it's a hillside facing west. There's enough flat land to build a few houses. There's 10 acres in all, mostly on the hillside. The container, which you can see next to my SUV, holds the equipment, a place to sleep, a small kitchen, an RV toilet. But this is high desert. It's not heated yet. I'm hoping to make that work soon. And the temperature this week, I think, was fluctuating between 95 degrees in the day and 42 degrees at night. That is high desert temperatures. Obviously, this site cost more than $14. I bought this 10 acres for $4,000, sight unseen on eBay. Probably 8 or 9 years ago. There are still deals, but not that good. And so it's unfarmable. And that's one of the reasons that it was not very expensive. The Milky Way, when I got this, was highly visible at night. Since then, a lot of part farmers have moved in, and Siskiyou County says you can grow 6 plants on your property. So they're all illegal pot farmers, but they have hundreds and hundreds of watts of greenhouse lighting all night. So I'm not sure I can still see the Milky Way with all of that on. And solar power and the overnight farming lighting cause interference at the site. So why am I thinking about a $14 remote rig controller? Obviously not for that site. It's meant to be for more mundane remote sites, such as your own home. It's an easy project intended for a QST article. There's no SMD soldering. I think the hardest things to solder are microphone connectors. Nothing that hams should find that difficult. There's already the RigPi, which you can get, I guess it's about $300 now. The $14 controller can do most of what the RigPi does. And it's meant to be better in some ways. There are a few things that the RigPi can do that it never will. For example, rotor control is still an open issue. I've got the IOs and probably the software room for it. I just don't know, what can we support. The project status is this is about half done. Most of the work so far has been systems programming. The board at this point automatically configures an external port on your router and registers a DNS address with dynamic DNS if your router has UPnP, that's Universal Plug and Play, enabled. And this is something that most routers have. It used to be a security issue. The software has been updated since then, so it is now safer to turn it on. And the board actually uses port control protocol rather than UPnP. But pretty much all the routers that support UPnP use a particular implementation called Mini UPnP. It is, of course, a open source project. All those routers are made from open source, whatever they say. And that software supports port control protocol, but it doesn't generally have a separate switch for it. So when you turn on universal plug and play, you get port control protocol as well. So in contrast, the RigPi doesn't do this. The RigPi requires manual configuration to open ports on your router. You can still do that, but this just makes the process easier. For a lot of people, configuration should be automatic. Indeed, I'm working on a fallback where if configuration isn't automatic, it tunnels its way out of your network to a server that will repeat it. So if that gets to work, it'll always be automatic configuration, no messing with your router at all. The licensing of this project is a Faro GPL3. That's an open source license. It requires that the source code must always be made available. It's an open source project, so collaborators are welcome. Currently, I'm the only person working on it. It doesn't have to be that way. This is the card that I'm using. So this is the ESP32 audio kit. And you can get this on AliExpress for about $14. And they'll mail it to you from China. It takes about 3 weeks to get it. Don't be afraid of dealing with vendors on AliExpress. I've spent thousands of dollars there. I got cheated once, and the AliExpress company actually caught it and refunded me before I even had to ask for it. So it is not quite as Wild West as people might tell you. It doesn't seem all that different from eBay. So this board is available for very cheap. On Alibaba, I buy them about 100 at a time for $11.50. It's manufactured by AI Thinker, and their Chinese name is Shenzhen X Inc. Technology Company Limited. Anyone else you see selling this is a reseller. You know, they all put a manufacturer's name on it as if they were the manufacturer, but they are not. This is the hardware architecture. So there's 8 megabytes of serial flash on this module. So this has the ESP32 CPU and audio chip and the flash chip. And 8 megabytes of serial flash is executed in place. So how do you execute serial flash in place? It's copied to RAM a page at a time and executed from the RAM. So it's very much like a cache scheme, if you understand how computer cache works. As you can see, it's got a whole bunch of IOs. You can put an SD card in it and have 64 gigabytes of writable data. It has a USB UART, so you just plug it into your computer with one connector, just a normal USB cable. Use a short one because they do have some noise sensitivity. And it will be powered through that. If you use the lower connector, that's power only, and it doesn't provide the USB data connection. If you use the upper connector, you get both. You can also give it a 5-volt battery or power supply directly. It has line inputs and outputs. It also has 4 ohm speaker outputs, about 3 watts for stereo speakers, and there are 2 microphones on the board. The line inputs are just inputs. The line outputs are shared with the amplifier. So they're either a line or you're powering a speaker, or you can have it power the speaker and the line output at the same time, but it's the same channel. There are 3 serial UARTs on the chip. You'll notice we have a bunch of pins available for I/O, but not too many. So we can't actually use all of the peripherals on the chip at once. The floating point performance is pretty bad. It's single precision only, hardware support only for addition and multiplication. Now, you know from algebra that if you want to divide, you can multiply by the inverse. So that's not quite as awful as it sounds. But we're not really sure that this can support soft modems with floating point or codec 2, which requires floating point directly on the board. Fortunately, you can also implement it in WebAssembly in the browser. The browser will be running on a platform that has great floating point. You can program and view the console through the USB serial cable. There is no special programming dongle. And you power it with a USB power supply. So just one board pretty much does everything that you need to control a radio and to handle the input and output of the radio. And up on the top, that black thing is antenna for Wi-Fi and Bluetooth. So this will connect the audio of your rig to the net. So the development software, users can flash the firmware from a web browser. There is no software required just to flash the firmware. There's software required for development, obviously, but it's free and it's really easy to install. It's a C programming environment with evolving support for the Rust language. It uses LWIP, which is a lightweight IP implementation for TCP IP, and it uses free RTOS, free real-time multiprocessing operating system. So it pretty much does everything that you would expect if you're programming on a Unix-like platform, but it does it with smaller embedded software. So obviously there are big differences between this board and the RigPi. First of all, the Raspberry Pi is much more powerful. You can run a full server on the Raspberry Pi and do all sorts of stuff besides just control your radio. The ESP32 audio kit doesn't have hardware USB master. It's possible to use the tiny USB software and sort of bit bang USB out of a couple GPIOs. I don't know if we'll be able to do that. There's Wi-Fi only for networking on this board, whereas the RigPi has both Wi-Fi and Ethernet. And the RigPi actually comes in 3 boards. It's a Raspberry Pi board, an audio board because the Raspberry Pi didn't have enough audio I/O on its card, and a keyer board. And, you know, if you're a systems programmer, you kind of scratch your head and ask, why is there a keyer board? Because we know that we can program things like keyers at interrupt level in the Raspberry Pi operating system, which is Linux. And Linux supports real-time just fine in a number of different ways. And the easiest way is just to code it into a device driver. So why didn't Howard do that? Why did Howard use a keyer chip? Because Howard isn't a systems programmer. He's a great guy. It's just, you know, we all have different training. Um, the RigPi was much easier to program. It comes with all of the system utilities you could want. I know because I wrote some of them, because the Raspbian OS in the RigPi is a derivative of Debian, and I was the second Debian project leader. I did a good deal of systems programming, including writing BusyBox, which is a sort of embedded Linux toolkit. It's all around you. It's probably in your phone, it's in your router. All sorts of devices run it. Um, but anyway, for the ESP32, we didn't have that great environment that comes with Debian. So I had to implement new lightweight versions of many of the programs that just came with the RigPi. Um, so SSNTP, that's network time setting, because this board doesn't have a battery clock. So it sets its time from the network whenever you boot it up. And it keeps accurate to within some small fraction of a second from then on. ICOMP v6, this uses IP version 6 and IP version 4. And ICOMP v6 is necessary to tell where your IPv6 router is. IP version 4 gets that another way with DHCP. Stun is a protocol that lets you determine how you get outside from your local internet. And it tells you what your outside IP address is. So I re-implemented all of these in tiny versions for this board. Port control protocol is something that tells your router to open a port automatically so that you don't have to configure an IP port on your router for this board. Dynamic DNS lets you set a web domain address for the board once it configures its IP address. It's all automatic. And then I did internal systems programming, an embedded event-driven IO facility, a new facility for submitting jobs to run in FreeRTOS threads, some web form handling software, a compressed ROM file system so that you can serve images, style sheets, static web pages from the ROM, and they're compressed in the file system. So it automatically decompresses them and doesn't use much space to hold them. And I wrote a C language framework for making dynamic web pages. So this has taken me a lot of time so far, and I'm now at the point where I can actually write the application. And fortunately, there's still lots of flash memory left there. There are 8 megabytes, and we essentially have used maybe 1.5 meg for all of the systems programming and the libraries that came with the SP32 programming software. There are a number of other projects using this board. There's a 1200 baud TNC by Dana, K6JQ, and he called this a hold my beer project. He just wrote a TNC on this board to prove it could be done. I think it's worthy of improvement, and a lot of the software that I've already written would make it a lot more usable. But right now, it just presents a TCP socket on the board. You connect to that port, and it's a KISS TNC for $14. And obviously, it could be made smart. You know, you can add a number of programming languages to this board. Lua is probably the smallest. Circuit Python also works, although it's more work for me to make that happen. There's another project called Project Boondock Echo that streams scanner audio to internet that uses this board as well. And there are lots of internet radios, non-ham streaming audio projects, all implemented with this board. So if you buy a board and you decide you don't want a remote rig controller, you can make it a TNC just by reflashing it. So the application architecture is we serve whatever static web objects we can from the compressed file system. It doesn't double compress images. It knows what they are and just doesn't compress them when it stores them to ROM. And dynamic web pages come from a C program, and I'll show you how I do HTML in C. So I implemented all of the HTML tags as C macros, and there's a library that supports them. If you include the header for them, then you can start interleaving HTML and C in a function, which is kind of ugly, but it works great. So this is an example. I hope this comes over the video. So this is a C function. It takes a printf pattern, and the printf pattern is the title of the page. So you can put as many variables in that as you want and expand them to text. And then we get to the HTML. Pardon me. And so as you can see, this looks like HTML, and I fall into some C at this point and emit the title that I set up at the top. So that is a little piece of web boilerplate that gets expanded at the top of every web page. And then this is how you do an HTML form. So form obviously is a HTML tag. It has attributes. These would be easier to write in HTML because they'd be right after this form word, but this was as far as I could stretch the C macro system without writing my own language preprocessor, which I felt wasn't worth the time. So these set the attributes of the form tag. And then here's an input. These set the attributes of the input tag and a label. And we set what the label attaches for and the text of the label. So this makes it pretty easy, although kind of ugly, to write HTML forms in C. And well, why am I writing these in C instead of another language? C++ is supported. Rust is kind of evolving, and it wasn't quite ready for me to use. But if I did this in C++, it would pull in a lot more library software. And remember, I only have 8 megabytes of flash to work with. Pardon me. So I'm paying a price here and using HTML in C rather than one of the more graceful languages we have today. So how do you connect all of this to the radio? It connects to a radio with CAT or CIV serial control protocols with a 1-wire plus ground TR switch, a straight key input, which is also 1-wire and ground, and audio inputs and outputs. That only takes up one of the stereo channels. So we have this whole right channel that we're not using. We can use it for a local speaker, local microphone, etc. And even if you have a radio without CAT or CIV, like an HT, you can plug this into an HT and just leave it on one channel and remotely access your local repeater wherever you are. So, you know, for what this costs, pretty much every radio everywhere in a house with internet can be remoted. You know, even those Wushin HTs. So this works because CAT and CIV are at both low voltage. They're 5-volt logic levels. The board that we're using is 3.3 volts. Its logic 1 is high enough to be detected by a 5-volt input, and it is tolerant of the 5-volt output from the radio in its 3.3-volt input. So it can connect directly to CAT or CIV if they're the logic level ones. If they are the RS-232 ones, which is a 12-volt thing, you need a logic converter that is probably a $2 part on AliExpress. And I/O expansion is possible. We only have a few I/O connections to work with because this board uses most of them. And we can do things like, well, we won't use the 6 buttons on the board. The first one is necessary to reset the board. But the other 5, we can use the I/Os from them. There's a programming interface that we don't use, the serial one. We only use the USB one. So we can use a couple more I/Os from that, but we're still I/O limited. So what do you do if you want to expand? Well, there are I/O expansion boards. These are also available from AliExpress for less than $2. And they can connect to the SPI bus. So that is a serial bus with a couple of wires and ground that can connect to 20 or 30 of these boards. Usually it's 8 of each kind. Anyway, it's more than you would want to connect to. So the ones I'm showing here are a dual UART board. This can also do RS485 and a 16 GPIO board. And 16 GPIOs is quite a lot. So potentially we can do things like use rotor control on this kind of expansion if we can't fit it on the normal board. What do we do if we want to add codec 2 or WSJT? We have FT8, FT4 to this board. It's software. Your radio doesn't come with those modes, but there's no reason we can't take this and add them to your radio. There are 2 ways to do it. The first is to implement it on the board. However, the floating point performance of the board might not be adequate, and the space is very limited. Or you can implement it in WebAssembly and run it on the web browser because you connect to this board with a web browser. Codec 2 is already in the port of FFmpeg to WebAssembly. So we know that can be done. And, obviously the platform that you are running the web browser on has a better CPU and memory than our board. So once you start implementing things in WebAssembly, you have really unlimited space. Indeed, you don't need to store all of the pages and programs used in your browser on the board. You can store them on any server on the net. And so we can serve things off the web that aren't even on the board, but they work with it. So what's not going to work? There's no SDR. You can't plug in your RTL dongle. If you have a radio like Flex Radio that's intended to have SDR software on a computer, you have a better way to remote that thing. So you can't use this for it. It's just not powerful enough to support it. So let's talk about blue sky stuff. For example, we can implement RS485. That's also called Modbus. Modbus is actually a protocol. RS485 is a serial data link. And this is used to control various devices over quad wire, telephone quad wire, two twisted pairs. And it can support 4,000 feet of them. So an RS-485 to logic level converter with lightning protection, that's a 4,000 volt protection. I don't know how that would work in real lightning storm, but that board costs less than $2 again on AliExpress. There's all of this stuff that's it's actually fine quality for next to nothing. And you can extend a control line with that about 4,000 feet and control multiple devices. So things like antenna switches. I know my solar controller in my remote site is RS-485 telemetry, and I have a weather station with RS-485 telemetry that could connect to our board potentially. But this is blue sky after we get the original part working. So here are some challenges. Fit everything in 8 megabytes. It probably will work. We might have to remove some of the less popular drivers from HamLib. And there's some that physically won't connect to the board. We can remove them. Lightweight IP is configured for 16 sockets maximum. I've already hit that. I think I have to change 3 configuration constants to get around that. I haven't tested it yet. It's all there in source, so no matter how much it needs, I'm sure I can hack it to have more than 16 sockets. So if you'd like to follow along or collaborate with this project, here's where you can find it on GitHub. And also please look at hamopen.org, which is developing technology like this and other sorts for support of radio amateurs. And I'll take questions now. Thanks very much to Carol for moderating. Hi there. So hopefully everyone can hear me now. And I'm going to go through the questions in the chat. So please type more questions in the chat. First of all, I have to apologize that this is a technical presentation because this is obviously a work in progress. I don't really have what it takes to make a presentation for prospective users yet, as Rick N6XI noticed. And the reason is I haven't written that part, so I don't have anything to show. And what I can do is tell you that it should be able to tune your radio and transmit and receive, etc. If
Hi,
you've
Bruce.
seen other controls like RigPi, it should act somewhat similarly to them. Okay, so I believe you found, if you search on AliExpress for ESP32 audio kit, you will find the board. There are 2 different boards. Yeah, unfortunately, you can't cut off the screen. You gotta grab that from the chat. And so the different boards. Let's get those in the light. Okay, so this is the one you want. It's the one with the ESP32 in the center on the top. That's this can here with the black antenna on the top. So this is the ESP32 audio kit board. Let's see how close I can get to the camera. And then this is another board called a Lyra. So this is the first version that was actually made by Espressif. You don't want this one because I have not made that version work yet. However, this is the one that is mostly being sold on AliExpress. And as I said, you can recognize it because the CPU is right in the top center. So let's look at more questions. The GitHub link, I'm sorry, I can't actually type into the chat. So you start with github.com/. The next part is my name, Bruce Perrins. So that's Papa Echo Romeo Echo November Sugar, all as one word. And then another slash and rig control, all one word. And that will get you there. I will put the presentation up on the GitHub site. Okay, so more questions.
Yeah, John KI5BEK asked, may I have a copy of your presentation? So I'm
yeah, I'll put that up on the GitHub site
okay.
along with the rest of the documentation. You can find quite a lot there already that is not in the presentation. There is documentation on all of the hardware, for example, which I think you'll find interesting because this board really can do a lot of ham radio projects, not just the one I'm working on.
Okay.
Yeah, okay. So you can't cut and paste from the screen, but at least you can type that one.
Yeah, it's
and
github.com/Bruce Perrins/rig control. That should work just fine.
Okay. And so is there going to be an Ethernet port? No, I can't make that work. I'm sorry. The deal is there just are not enough IOs on the board to make that work and also make the ham radio and everything else work. Okay, if you can see the chat, you can yeah, okay. So the I'm sorry, I'm skipping over questions.
Hey, Ray,
but if you can see the chat, you can now copy the GitHub link from it. The board in my presentation had 6 buttons, and this appears to have 8. And one of them is reset and one of them is program. And I think that is the difference. You don't generally have to push them. I've actually made the board. I've made the board not work into its normal ROM, which makes it look for the programming signal, and then I've had to hold down reset and program until it's time to until I reprogram the board again. But the version that may show 6 buttons in the picture actually comes as this version. And as far as I can tell, they're all made in one factory, and that's AI Thinker, and that's the one that they are shipping now. Get the one with the CPU in the top center. Do not get this one. As you can see, this has buttons and touch pads, and it's got the CPU on the side instead of the center.
For the benefit of those who are following this presentation in audio format, they're asking us to read the questions in their entirety before we answer them. So this one from Eric W3EAB says, what other projects are hamopen.org working on?
Well, hamopen.org was formed to be an organization that handles money. And the idea is if you want a grant from ARDC, ARDC is a whole story on its own. They were the IP version 4 organization for amateur TCP IP, which not many of us ever used, but I have. And they owned the entirety of Net44 in IP version 4, and they still do own 3/4 of it, and they sold the upper 1/4 to Amazon for $134 million. And so they have some money to give amateur radio projects, but for their own legal and tax compliance, they have to give the money to 501c3s. The paperwork gets harder. So we founded Ham Open to be a 501c3, which could act as a channel to other projects. And we are still waiting on our 501c3 application with the IRS. So we can't actually do that yet. But we're working on this project, and we have other projects which we wish to sponsor, and we are evangelizing at amateur radio conferences. One of them is this wonderful guy who makes electric thrusters for microsatellites. And so we were showing his projects. When there's a project like that that can seriously advance amateur radio, for example, we are not going to get satellites in the air anymore if we don't have a plan to deorbit them. FCC is not going to let us do that. And so we have a guy who makes electric thrusters, actual satellite rocket engines, in his basement. He's got the vacuum set up. So far, I've done a $6,000 race for him to get a vacuum pump, this really fancy oil pump that helps him get a high vacuum. But we would like to do much more for that guy. And there are a number of other high-tech projects in that vein that we would like to sponsor. M17 is already getting help from Open Research Institute and ARDC. We want to help them as well. We also, if you go on hamopen.org, we talk about the tax complications. And they are pretty serious. And this is something that I had to research and am now documenting for everyone else. I also did a project on ITAR, the International Trafficking in Arms Regulations, and the Export Administration Regulations. These are the two sets of laws that the United States has about exporting technology. We had to get around them so that we could have open source satellite projects. I wrote that policy. Open Research Institute did the legal work. They submitted this to lawyers who submitted it to Department of State and Department of Commerce. So I now have a policy approved by the government that allows you to do open source space projects, and it doesn't matter what people from what country participate. So that helps very much for amateur radio. Let's see, what other questions do we have here?
Well, Ernie posted a sample of a link to the board on AliExpress.
Right. There are a number of different vendors on AliExpress. And then if you're sophisticated, and of course you can buy more than just this board over there, there's also Alibaba. And Alibaba has the vendors who are selling things in quantity. So over on Alibaba, I bought 100 of these boards for $11.50 each. And unfortunately cost $70 to ship the box. So that appreciably added to the expense. But I got below the 14, and thus I can go to a ham radio conference and sell these boards and recover my overhead. We do it for Ham Open, so it's a nonprofit. Um, so,
Great.
you're very welcome.
Many thanks. Very interesting and
And I'll
exciting
answer
project.
one other question, which I've gotten before. If you have any more questions, type them into the chat. Um, and the question is, why aren't you using board X, where the board is a Beagle bone, or it's a Raspberry Pi Zero W, or it's something else? Well, this particular board allowed me to do everything for $14 without any more parts other than connectors. And there will always be a better board. And next year, I may be using a different board, because a board, for example, with floating point or an Ethernet port comes out at that price point. And I am always interested in hearing when you notice a board like that. But this particular one, for example, it has an SD card socket, but you don't need to buy and pay for an SD card and stick it in there for the basic functionality to work. All of the little Linux boards, where little Linux boards, run about $20-$30 for some of the Chinese Raspberry Pi lookalikes. The Orange Pi comes in 7 or 8 versions. Those all had a bill of materials. It was somewhere north of $50 to make them actually work. They didn't have the audio on the board. They needed an external memory card to be plugged into them, etc. So that's why I am using this particular board. And again, technology changes. So as boards like this come out at that price point, if you notice, please tell me. I think we're out of questions, Carol.
Sure does look like that.
Okay, so we're going to let them all take their potty breaks before the next talk. And thank you very much, Carol, for moderating. And thanks everyone
My
for
pleasure.
participating. I am Bruce Perrins, K6BP. My email is the same as my name. It's bruce@perrins.com. And I even have a phone number. It's 510, the number 4, and my name, Perens. Thanks very much.
It's a new question.
Oh, our audio in and out, line level or speaker and mic from the radio. I believe that we have a microphone level input, which you might have to pad down from the radio. And we have a line level output and a speaker output. And there is a software switch to turn on or off the speaker amplifiers. We also have 2 channels, and we are only using one so far. So we can use line on one and speaker on the other. So, and unfortunately, I'm not at the point where I actually have the program working and have tested this with the radio. Thanks very much. Kilo 6 Bravo Papa out.
My name.